Hello everyone, I am Ashraf. Welcome to my maths learning platform A Square. Today's topic for me is domain of real functions. What's called domain? Domain is the set of all x values. For example, when you consider f of x is equal to 1 over x, you know that x cannot be 0. If x is equal to 0, the y is becoming 1 over 0, which is not defined. Another example, if f of x is equal to square root x, you know that square root of negative number is not a real number. So negative numbers cannot be given for x. So what all values can be plugged into the function as the values of x? That set of x values is called domain of that function. So there are some limitations for x values. So we will see for different kinds of functions what all could be the limitations of x values. First of all, we consider polynomials. For example, f of x is equal to 2x minus 1, or we can say y is equal to 2x minus 1. What all values can be given for x? X can be a negative number, x can be a positive number, x can be any real number. It can be irrational number also. You can get another irrational number as y value. So x value can be any real number. So in this function, the domain is the set of real numbers. So the domain can be explained as the set of real numbers, or it can be denoted by r. When you denote the set of real numbers by r, there will be double line for r. It can be written as negative infinity to infinity also. Take any polynomial. For example, f of x is equal to x cubed minus 2x squared plus 3x plus 4. In this, x can be any real number. So, if the function is a polynomial, then the domain will be the set of real numbers. Let's consider other functions. For example, a rational function. F of x is equal to px divided by qx. In this, the condition, the limitation is the denominator should not be 0. That is, qx is not equal to 0. For example, if you take 1 over x minus 2, for this function, fx is equal to 1 over x minus 2. X minus 2 cannot be 0. That means x cannot be 2. So any real number which is not equal to 2 is the domain of this function. So we can write it as r minus the set of 2. Or you can write negative infinity till 2 and 2 till infinity. Here you can see the bracket for 2 is the open bracket. That means 2 is not included in that. Take other examples for rational expressions like fractions. X plus 2 by x minus 5. What's the limitation? The denominator cannot be 0. That means x minus 5 cannot be equal to 0. That means x cannot be equal to 5. So your domain is r minus set of 5. Or it could be minus infinity to 5. Union 5 till infinity. Take another example. In this, the denominator is x square minus 8x plus 15. X square minus 8x plus 15 cannot be 0. When you factorize it, you get x minus 3 into x minus 5 cannot be 0. That means x minus 3 is not equal to 0. X minus 5 also is not equal to 0. X cannot be 3 or 5. That means r minus set of 3 comma 5. It can be represented like this also. What about the function fx is equal to 3x plus 1 divided by x square plus 3? But x square plus 3 can never be 0. because x square can never be negative 3. X square will be always positive. For this function, there is no possibility for the denominator to be 0. So for every x value, it is real. That means the domain is the set of real numbers. Thirdly, we consider the function fx equal to square root of px. That means square root of any polynomial. For example, square root of x minus 1. If the function is square root of a polynomial, the function inside the square root, that is in this particular question it is x minus 1, should be greater than or equal to 0, because root of negative number is not a real number. So here we have to put p of x is greater than or equal to 0 in general, or x minus 1 is greater than or equal to 0. That means x is greater than or equal to 1. So x will be from 1 till infinity. Second example of square root function. Root of x square minus 8x plus 15. So the function inside root is x square minus 8x plus 15, which should be greater than or equal to 0. When you factorize, you get x minus 3 into x minus 5 is greater than or equal to 0. When the product of two numbers is greater than or equal to 0, we normally draw a number line. Then we mark these two numbers, 3 and 5. Now, this number line is divided into three parts. Before 3, in between 3 and 5, and after 5. Which all parts will be satisfying this one? Let us check. If you take a number before 3, for example 2, and plug into x minus 3 into x minus 5, what's happening? It's positive. So this inequality becomes correct. A number in between 3 and 5, say 4. When you substitute 4 in this is a negative number. So this is wrong. Then take a number after 5, say 6. Then substitute in the inequality. What do you get? It's positive. So this part also is included in the domain. So which are included in the domain? Negative infinity till 3 and 5 till infinity. This can be denoted by negative infinity 3 union 5 till infinity. Another example for square root function, it is root of 9 minus x square. So here the polynomial inside is 9 minus x square, which should be greater than or equal to 0. That means 3 minus x into 3 plus x is greater than or equal to 0. Same like the previous one, we will draw a number line and we will mark negative 3 and 3. So which are satisfying this inequality? Let's check it. You can see that only the part in between minus 3 and 3 will be satisfying this inequality. So the answer is negative 3 till 3, both are included. Because greater than or equal to symbol is there, so both are included. Hope all of you like this video. Thank you so much.